there's one more thing to talk about in section 3.2, and that's whether functions are discrete or continuous. And in section 3.1, I did mention continuous a little bit, but I didn't mention discrete. Discrete is a set of input values that consist of only certain numbers in an interval. So when we're talking about a discrete domain, we're talking about very specific numbers. And what this looks like on a graph is that the graph is points. It's dots. It's very specific points on the graph. For a continuous domain, it's a set of input values that consists of all numbers in an interval. So if you think about this pencil here and how I could trace this image, I was able to do that continuously. So a continuous domain is when I have a curve. So if I have a graph that looks like this, if I have a curve, or if I have a coordinate plane and I draw in a line, oh, I wanted a different color. If I draw in a line, these would be examples of continuous because we're talking about every single point in between. Where a discrete domain is going to be just the points, just scattered points basically. Now they might not be completely scattered. They could be linear. They could be, I could draw a line through them, but if I'm just looking at very specific points, so this would be an example of a discrete linear graph, something that looks like this. It's increasing at the same amount, but I don't connect them. This is an example of discrete, where down here, when I can constantly trace without lifting my pencil, that becomes continuous. So let's take a look at how we're going to use this. We have a linear function, y equals 15.95x, represents the cost y in dollars of x tickets for a museum. Each customer can buy a maximum of 4 tickets. Find the domain of the function. Is the domain discrete or continuous? Explain. Well, if you're buying tickets, are you going to buy a whole number of tickets, or can you buy a partial number of tickets? For example, can you buy 1.25 tickets? Can you buy 2.36 tickets? No, you have to buy a whole number of tickets. So this is going to be an example of a discrete domain. So it's discrete because you have to buy a whole number of tickets. So what is that domain? So that domain is going to be x values. Let's see, a maximum of 4 tickets. That's important to remember. So we could buy 1 ticket, we could buy 2 tickets, we could buy 3 tickets, we could buy 4 tickets. Graph the function using its domain. So let's use an input-output table. Let's use an XYT table. So my inputs are 1, 2, 3, 4. And then to find my output, I'm going to have to use that it's 15.95 times x. So we're going to have 15.95 times 1 which is 15.95. Then we're going to have 15.95 times 2, which I cannot do that one in my head, is 31.9. And since we're talking money, I'm going to say 31.90. 15.95 times 3. $47.85. And then 15.95 times 4. $63.80. And now we plot our points. So one ticket is 15.95. So this is $10, this is $20. So we'll need to estimate about where that point goes. 2 tickets is at 31.90. So we need to estimate the next point as well. 3 tickets is, so 10, 20, 30, here's 40. 47.85, probably about right there. And then 4 tickets, 63.80, 10, 20, 30, 40, 50, 60, 380. And they should appear fairly linear because we have this constant rate of change. It increases $15.95 for each ticket. Let's take a look at our next example. A cereal bar contains 130 calories. The number C of calories consumed is a function of the number B of bars eaten. Does this situation represent a linear function? Well, is it going to increase the same amount for each bar you eat? Is the rate of change going to be the same? I believe so. That constant rate of change is the number of calories per bar. Let's see, or actually, yeah, number of calories per bar. Find the domain of the function. Is the domain discrete or continuous? Well, is it possible to eat just part of a cereal bar? Can you eat 2 1/4 cereal bars? Can you eat just 1/3 of a cereal bar? Do you have to eat an entire cereal bar? Because you don't have to eat the entire thing, this one would be continuous. Because you can eat partial bars. Now, as far as the domain is concerned, can we have a negative number of cereal bars? I don't think so. But we can have more than 0 cereal bars. And I'm going to go ahead and include 0 cereal bars. So when our domain, which is our input, is B, is greater than or equal to 0, is going to describe our domain. So graph the function using its domain. Again, we can just create a bit of an input-output table. I'm just going to go ahead and use 3 input values. And we know that it's 130 calories for each cereal bar. I'm going to go ahead and use 0. Let's just go 1 and 2. Small enough numbers. So when we have 0 bars eaten, there should be 0 calories consumed. For 1 cereal bar, it is going to be 130. For 2 cereal bars, it's going to be 260. And let's plot those points. So 0, and then at 1, we're at 130. And then at 2, we're at 260. And then because this is continuous, we are going to graph an arrow through them. If we were in geometry, I would call this a ray because it's only extending in one direction. So we would have a graph that looks something like this, and because it's extending in one direction, I'm going to put an arrow on the end to show that it goes on forever in that direction. And that would be how we would show the continuous function of the cereal bar situation. So here's a U-try. Pause the video, take some time to think. Is the domain of each function discrete or continuous? You do not have to find the domain, just is the domain discrete or continuous? Now that you have found or had some time to think on it, you should have said that for the first graph, it is not, I was about to write discrete, but it is not discrete. The first graph is continuous. It is all points in the domain of 0 to 6. So I'm actually going to write the domain here because when we can write the domain as a compound inequality, that's another example of it being continuous because we're showing every single point in between. The second graph is going to be discrete. And the reason why is it is a graph of very specific points. So continuous, again, you could put your pencil on it and trace it continuously. Discrete is going to be very specific points. And that is the difference between a continuous function and a discrete function.